Hello students, in this video I would like to explain preparation of haloarenes under the chapter haloalkanes and haloarenes. Preparation of haloarenes means how to bring halogen in the benzene ring. First of all, halogenation of benzene, that is electrophilic substitution, can be carried out. Here, say benzene is treated with halogen, chlorine or bromine in presence of iron as a Lewis acid catalyst. Actually, iron reacts with halogen to form the respective iron halide that acts as the Lewis acid catalyst and helps to form the positively charged halogen group, which gets substituted, which is substituting the hydrogen from the ring. As we know that this is the process of formation of chlorobenzene or bromobenzene when chlorine is in presence of FeCl3 or Fe and bromine in presence of FeBr3 or Fe reacts with benzene to form respectively chlorobenzene and bromobenzene. Now in this reaction, iodination, that means in presence of iodine and respective Lewis acid catalyst cannot give the iodo substituted product in the benzene ring because the formed HI helps the reaction to go back, and that's why to remove the HI we need to add some oxidizing agent like HNO3 or HiO4, etc. Rather, in other way, iodine can be taken into the ring. So I will come to that process later on. Now you follow that. As an example, if substituted benzene, that is toluene, when treated with is carried out with the halogenation reaction, electrophilic substitution reaction, since CH3 group is an ortho-para directing group, so we get the ortho and para substituted product, where para substituted product is major one due to less steric hindrance. Now here you follow that if the reagent is this one, that is halogen, chlorine or bromine in presence of sunlight or heat, if it is given, now the substitution takes place at the alkyl group. Here free radical substitution at the side chain takes place. So from toluene we will be getting the benzyl chloride. So it is not an haloarene, it is it is aliphatic compound substituted. You can say that 1-chloro, 1-phenyl, methane. So it is not haloarene, as because halogen is not directly attached to the benzene ring. So here I have written another example, that is when this ethyl benzene is treated with chlorine in presence of sunlight. You can follow that the substitution takes place at the first carbon because it is a free radical, it follows a free radical mechanism, and the free radical formed here at this first carbon gives rise more stable free radical, and that's why the substituted product is this one. The name will be 1-chloro, 1-phenyl ethane. Now let us come to another way of preparation of halobenzene. It is from diazonium salt. We know that primary amine, that is aniline, aromatic amine, when treated with NaNO2 HCl, that means nitrous acid at low temperature 0 to 5 degrees Celsius, benzene diazonium chloride is formed. Now this benzene diazonium chloride, if it is treated with HCl in presence of Cu2Cl2, cuprous chloride, or HBr in presence of Cu2Br2, chlorobenzene and bromobenzene is formed. It is a name reaction known as Sandmeyer's reaction. Now the same process can be carried out as it was shown by Gattermann. It is known as Gattermann reaction. Instead of cuprous chloride and cuprous bromide, directly metallic copper can be used with HCl and HBr to form the chloro and bromobenzene from benzene diazonium chloride. Now to bring, other than chlorine and bromine, to bring iodine, we can treat diazonium chloride with Ki, so we can get the iodobenzene. But to bring fluorine into the benzene ring, we go through this process. When this diazonium chloride is treated with HbF4 fluoboric acid, then the fluoborate is formed. This diazonium salt of the fluoborate ion is formed, which when heated, it is giving rise the fluorobenzene. So here we can follow that we can prepare chloro, bromo, iodo as well as fluorobenzene. Now let us look into some other process also, where say from diazonium chloride, if we treat diazonium chloride with CuCN and KCN, then a carbon comes into the ring. That means we can enhance the carbon in the benzene ring, and when it is reduced, it forms the aliphatic amine. This is phenyl substituted aliphatic amine, and when it is treated with the same reagent NaNO2HCl, that is nitrous acid, like here, the aromatic amine gives stable diazonium salt, but the aliphatic amine, primary amine, does not give the stable diazonium salt. Initially the diazonium salt that is formed, that is changes to alcohol. So now this alcoholic group is not into the ring, it is at the side chain. That's why when substitution is carried out, it gives rise the substituted aliphatic compound like this one. You can follow that we came from toluene to here, and here we came from diazonium salt to benzyl chloride. Okay, so these are some transformation that we need to learn during the process of learning this preparation of haloarene as well as substituted halogen compounds of aliphatic compounds. So these studies can be carried out side by side. Here the processes are bringing the halogen into the ring, and here some examples are given where the halogen are coming at the side chain, but there is some substitution with benzene ring. So these are not the haloarenes. Okay, thank you.